What we're going to do is look at interval notation. Interval notation is another way of stating the domain and range. It's a little bit simpler. This is used a lot in pre-calculus using interval notation. What we're doing is we're moving away from the greater than and less than, and we're moving into parentheses and brackets. So when we have a statement that includes the value, what we do is we put a bracket. And then when we have inequalities that do not have a line underneath it, what we do is we have a parenthesis. So what we're doing is we're moving the brackets and the parentheses as our inequalities. Now, with interval notation, always goes from least to greatest. So your least value goes first, comma, your greatest value. The other thing that we talked about was XER. X is all real numbers. What we use for interval notation is negative infinity to infinity. Notice that this is in parentheses because we never reach negative infinity and we never reach infinity. So looking at our first example, when we're looking at our domain, we're talking about our x values. So it starts at 0 and then it ends at 4. Now, when we're looking at our range, our lowest value is 0, and then our highest value is 4. Now, if we're looking at the next one, notice that we have the arrows. So when we're talking about our domain, it goes to the left, it goes to the right. So that means that instead of putting XER, what we're going to do is we're going to put negative infinity to infinity. Now, when we're looking at our range values, the lowest value is negative 3, and it keeps on going up. So negative 3 to infinity. Now, if we're looking at letter C, what we have is our domain is at negative 2, and it goes to the right, so it's going to infinity. Notice an open circle. So when we're talking about our domain, it does not include the negative 2, so we put a parenthesis, and then it goes to infinity. Now with the range, notice that it's going down. Now it always goes least to greatest, so since it's going down, it's negative infinity would be our lowest, and it goes all the way to negative 1. Notice that we do not include the negative 1, so it's a parenthesis. Pause it for a second, see if you could do the next 3 on your own, and then check to see what the answers are. So with letter D, with the domain, what we're doing is looking at our x values. So what we have is negative 3. It includes it, so we have a bracket. The 1 also is included, so another bracket. With the range, we're talking about our y values. So our lowest value is negative 3. Our largest value is 4. With the letter E, with the domain, it's going to the left. So that means that for the domain, it's negative infinity, and then it's stopping at 2. So we put 2 with a bracket. With the range, notice that the arrows are going up, the arrows are going down. Our least value goes first, our greatest value goes second. For letter F, when we're talking about our domain, we're talking about our x values. Notice it's an open circle at negative 2. Notice that we have a closed circle at 3. When we're talking about the range, our lowest value right here is negative 2. Our highest value is 3. Both of those are included, so for our range, they're both going to be brackets. Now what we're going to do is we're going to look at some of the summer packet material. So we're talking about writing in scientific notation. Scientific notation is a number in between 1 and 10. And then our exponent is a integer. It's an element of positive and negative whole numbers. So looking at this number right here, we need our 24,000 to be a number in between 1 and 10. So that would be 2.46 times 10. If we don't see a decimal, we know that it's at the end. And then we go 1, 2, 3, 4 in order for it to become the 2.46. Because that's a large number, that would be 10 to the fourth. Now for letter B, we're first going to put our number in between 1 and 10. So that would be 3.78 times 10. And we go 1, 2, 3, 4 spots. So that would be negative 4. Now looking at letter C, we're going to multiply the 7 and the 5, and that gives us 35. And then we add the exponents. 2 plus 6 is 8. So times 10 to the 8th. Now with this right here, notice that this is not in scientific notation because 35 is not a number in between 1 and 10. So we're going to change it to 3.5. That would be scientific notation. We're moving the decimal over once, so we're adding one more to the 8, so that means 10 to the 9th. Now, for the next example, what we're doing is we're writing it in standard notation. This would be a normal number. Notice that we have a negative exponent. Negative exponent means that it's a small number. So we're taking this decimal and we're moving it 3 spots to make it a smaller number. So we have 0.00224. And that would be our standard notation. In the same way, this one right here, it's a positive 4, so we move it 4 spots. 1, 2, 3, 4. So we're going to put zeros as placeholders. 7, 2, 6, 0, 0. Oops, put the comma in the wrong spot. 72,600. Now letter C. I'm going to multiply the 4.5 by 3. And that gives me 15, 12, 13. So that would be 135, but the decimal needs to be moved over once. So that would be 13.5 times 10. 5 plus negative 9 is negative 4. So negative is a small number, so I'm making a small number. 1, 2, 3, 4. There's going to be 2 zeros as placeholders. And that right there gives me my answer.